Introduction to Econometrics Lecture 1 Introduction and Review of Statistics. What is statistics? Statistics is collecting raw data, manipulating raw data, summarizing data types of statistics, descriptive statistics, used to summarize and describe data. Example: the Detroit foreclosure rate was 5% in 1997. Inferential statistics try to reach conclusions that extend beyond the immediate dataset. Estimation hypothesis testing draw conclusions. Example: at 99% confidence, living in an area with a significant cancer risk lowers housing prices between 11% and 20%. Data. Data sources are experiment, collect yourself and observational data, administrative records or surveys, collect through data owner. Data types. Cross-sectional, data on different entities for a single time period. Time series, data for a single entity collected at multiple time periods. Panel data, data for multiple entities in which each entity is observed at 2 or more time periods. Repeated cross-section, a collection of cross-sectional datasets, where each cross-sectional dataset corresponds to a different time period. Economic theory. Economic issues are anything dealing with the interaction of agents. Economic theory specifies relationships between variables of interest. Econometrics Stock and Watson stated that econometrics is the science and art of using economic theory and statistical techniques to analyze economic data, which includes testing economic theories, fitting mathematical economic models to real-world data, using historical data to give policy recommendations, using data to forecast future values of economic variables, estimating causal effects. Econometrics is a combined discipline of statistical theory, data, and economic theory. Quantitative questions and quantitative answers. Many decisions in economics, business and government hinge on understanding the relationship among variables in the world around us. Economic theory provides clues about the direction of the answer. But decisions require quantitative answers to quantitative questions. Therefore, we will develop a framework that provide both a numerical answer to the question and a measure of how precise the answer is. Wages example. A classic question in economics is the effect of education on wage outcomes. Respondents' wages are plotted against years of education for 2,731 full-time 29 to 30-year-old workers. The spread around the regression line increases with the years of education, indicating that the regression errors are heteroscedastic. Scatterplot data from 420 California school districts. There is a weak negative relationship between the student-teacher ratio and test scores. The sample correlation is -0.23. Although larger classes in this sample tend to have lower test scores, there are other determinants of test scores that keep the observations from falling perfectly along a straight line. Steps in an econometric analysis. Number 1 is formulate an economic model, formulate a theoretical model, or use economic theory and economic reasoning to informally formulate a relationship between the variables of interest. Number 2 is from the economic model to an econometric model. Specify the functional form of the relationship, linear, log linear. General, y is equal to beta naught, which is intercept, plus beta 1, which is slope coefficient, multiply by x plus mu, which is error term. We call the left side variable y the dependent variable and the right side variable x the independent variable or explanatory variable. Number 3 is collect data for the problem at hand. Number 4 is estimate the econometric model. Number 5 is use the estimates for statistical inference. Step 4. Estimate the econometric model. Choose an estimator to produce estimates of the relationship we are interested in. An estimator, a mathematical procedure, rule, used on sample data. The estimate is the actual value taken by the estimator in a specific sample. Types of estimators: linear regression with single or multiple regresses, nonlinear regression functions, regression with panel data, regressions with binary dependent variable, instrumental variable regression. Is the estimated econometric model of high quality? It is important to evaluate whether the coefficient is unbiased, consistent, efficient. Step 5. Statistical inference. Use the estimates to draw conclusions about the size of economic parameters. Predict economic outcomes, macroeconomic forecasting. Test hypotheses. Do class size matter for student learning? Evaluate policy. Will the new limit on toll-free goods harm Norwegian firms? But are the estimates reliable? Reliability and validity. Reliability is the consistency of an instrument or measurement, while validity is the accuracy of an instrument or measurement. You will also learn to evaluate the quality of econometrics studies by looking at internal validity and external validity. Internal validity is the confidence we place in the cause and effect relationship. In other words, it addresses the question, to what extent does the research design permit us to say that the independent variable A causes a change in the dependent variable B? While external validity is the extent of generalizability of the results of a causal study to other field settings. Notation. Sigma is shorthand for addition. Suppose xi is the ith observation. By adding x1, x2, x3 is equal to sigma xi. In general, we denote a variable with the subscript I, exxi, where I is either the time period or the entity number depending on the data type. When we need to be precise about using time series data, we use the subscript t instead of I. When we use panel data, we use both subscripts, yit, xit, where the first subscript is the entity and the second the time period. Measure of central tendency. Mean, median and mode. The expected value and is the most common measure of the central tendency. The EY is equal to product of mu and y, and the rest of formulas are given on this slide. Median is the midpoint of the data. To calculate it, the first step is to order data. In step 2, you have to calculate sum of n plus 1 divided by 2. In step 3, take the value at n plus 1 by 2 or the average of the two closest if it is not a whole number. Mode. The value that occurs most often. Measure of variation. Sample variance, the most commonly used measure of dispersion, summarizes how far a typical observation is from the mean. Why do we divide by n1 instead of n? The reason for the second modification, dividing by n-1 instead of by n, is that estimating product of mu and y by y introduces a small downward bias in total variation. Dividing by n-1 instead of n is called a degrees of freedom correction. Estimating the mean uses up some of the information, that is, uses up 1 degree of freedom, n the data, so that only n-1 degrees of freedom remain. Sample standard deviation is the square root of the variance. N. Range. A measure of data dispersion, though not used for many applications. To calculate, step 1 is to identify the largest observation. Step 2 is to identify the smallest observation. Step 3 is to take the difference. Measure of shape skewness. Measures the asymmetry of a distribution. A positive skewness implies that the tail on the right side is longer or fatter than the left side. A negative skewness implies that the tail on the left side is longer or fatter than on the right side. The formula of skewness is bordered with blue color. The negative skewed distribution is given on left side while positive skewed distribution is given on right side. Kurtosis is a measure of how much mass is in the tails of a distribution. The formula of kurtosis is bordered with green color. The left graph shows low kurtosis while right side graph shows high kurtosis. If a random variable has extreme values, outliers, the kurtosis will be high. The kurtosis is unit-free and cannot be negative. Percentile. A percentile is a measure that indicates the value below which a given percentage of the observations in a group fall. For example, the 20th percentile is the value, or score, which is greater than 20% of the scores. Measures of distribution in Stata by using command sum pop growth. Press Enter. We will get observations, mean standard deviation, minimum and maximum values of population growth for percentile used command. Sum pop growth, det. Press Enter. You will get percentile values at 1%, 5%, 10%, 25%, etc. You can also get observation, sum of weights, mean standard deviation, variance, skewness and kurtosis values. Illustration. Distribution in Stata. By using command hist pop growth, frequency normal. Measure of distribution. It can be used to simply describe the data. But it can also be used to test econometric models. Data scaling. What happens if we scale variables by adding a constant? So by putting values in formulas you can get required values of there for variance in example 1 and value of 1 for variance in example 2. Thus the mean is affected by adding a constant, but not the dispersion. Review of probability. Key terms. An experiment is a process whose outcome is not known in advance. Possible outcomes, or realizations, of an experiment or events. An outcome is a mutually exclusive result of the random process. The set of all possible outcomes is called the sample space. A variable is discrete if number of values it can take is finite, or countable. A variable is continuous if it can take on any value on the real line or in an interval. Random variables and probability distribution. A random variable attaches a value to each possible outcome of a random process, experiment. Realization of a random variable is the value which actually arises. The probability reflects the likelihood that an event will occur. The probability of event occurring will be denoted by probability of A. The marginal probability distribution is the set of all possible outcomes and their associated probabilities. The cumulative probability distribution is the probability that the random variable is less than or equal to a particular value. Joint probability. It is the probability that two, or more, random variables take on certain values simultaneously. Two variables are independent if knowing the value of one of the variables provides no information about the other. Probability of A and B is equal to probability of A intersection B is equal to product of probability of A and probability of B. Conditional probability. The conditional probability is the probability that one event happens given that another event has occurred. The formula of conditional probability is given on this slide. Covariance. Covariance describes the relationship between two random variables. It measures the linear association between the two variables. The formula of covariance between x and y is equal to subtracting product of ex and ey from exy. Correlation is computed by using the covariance and the variances. The formula of correlation is diving covariance by square root of variance of x and variance of y. It is between -1 and +1, where -1 means perfectly negatively correlated and +1 means perfectly positively correlated. Probability and regression models. Assume y is a random variable. Regression model provides description about what probable values for the dependent variable are. X. Y is the price of a house and X is the size of a house. What if you knew that X is equal to 5,000 square feet, but did not know why? Econometricians use probability density functions, PDF, to summarize which are plausible and which are implausible values for the house. Can, for example, look at typical values in a dataset. Reminder of rules of expectation are 4 while rules of variance are 3. A random variable. Some definitions. Outcomes are the mutually exclusive potential results of a random process. Your grade on the exam, the number of days it will snow next week. Random variable is a numerical summary of a random outcome. The number of days it will snow next week is random and takes on a numerical value from 0 to 7. There are two types of random variables. Discrete random variable takes on discrete number of values, like 0, 1, 2. Continuous random variable takes on a continuum of possible values. Probability distribution of a discrete. Each outcome of a discrete random variable occurs with a certain probability. A probability distribution of a discrete random variable is the list of possible values of the variable and the probability that each value will occur. Let random variable S be the number of days it will snow in the last week of January. Outcome in example are from 0 to 7 while probability is 0.20 to 0.01, respectively. Cumulative distribution of a discrete. It is the probability that the random variable is less than or equal to a particular value. The probability that it will snow less than or equal to S days, so FSIS equal to probability of S is equal or less than S, is the cumulative probability distribution of S evaluated at S. A cumulative probability distribution is also referred to as a cumulative distribution or a CDF. Look at example how the CDF is computed by taking same value as probability for 0 outcome, which is 0.20, while by adding to 0.25 gives 0.45 for outcome 1 and so on till outcome 7, which gives 1. Probability distribution of a continuous random variable. Tomorrow's temperature is an example of a continuous random variable. The CDF is defined similar to a discrete random variable. A probability distribution that lists all values and the probability of each value is not suitable for a continuous random variable. Instead, the probability is summarized in a probability density function, PDF, or density. Measures of the shape of a probability distribution. Expected value. The expected value or mean of a random variable is the average value over many repeated trails or occurrences. Suppose a discrete random value y takes on k possible values and formula of EY is given on this slide. The expected value of ES is 2.06. Expected value of a continuous random variable is also given, which is EY is equal to product of mu y. Measures of the shape of a probability distribution. Variance. The variance of a random variable y is the expected value of the square of the deviation of y from its mean. The variance is a measure of the spread of a probability distribution. Suppose a discrete random variable y takes on k possible values, thus the formula of variance, which is bordered with blue color. Through this formula, by putting values of outcome, mu value is 2.06 and multiply by outcome probability, we get variance of S value is 0.01. Mean and variance of a Bernoulli random variable. A Bernoulli random variable is a binary random variable with two possible outcomes, 0 and 1. For example, let B be a random variable which equals 1 if you pass the exam and 0 if you don't pass. The formula of expected value of B, variance of B and standard deviation of B is bordered with blue, green and yellow color. Mean and variance of a linear function of a random variable. In this course we will consider random variables, say x and y, that are related by a linear function. Equation y is equal to a plus bx. Suppose Ex is equal to mu and variance of x is equal to sigma. Thus by putting values we y is equal to a plus b mu x while variance of y is equal to product of b square and variance of x. Two random variables and their joint distribution. Most of the interesting questions in economics involve two or more random variables. Answering these questions requires understanding the concepts of joint, marginal and conditional probability distribution. The joint probability distribution of two random variables x and y can be written as probability of big X is equal to small x, probability of big Y is equal to small y. Let y equal 1 if it snows and 0 if it does not snow. Let x equal 1 if it is very cold and 0 if it is not very cold. Look at example. We get one probability by row and column wise total. Two random variables and the marginal distributions. The marginal probability distribution of a random variable is just another name for its probability distribution. The marginal distribution of y can be computed from the joint distribution of x and y by adding up the probabilities of all possible outcomes for which y takes a specific value. The formula of two random variable and the marginal distribution is bordered with blue color. The probability that it will snow is 0.22. Which is the first row total value in table as well. Two random variables and the conditional distribution. The conditional distribution is the distribution of a random variable conditional on another random variable taking on a specific value. The conditional probability that it snows given that is it very cold in example 1 is 0.5. In general, the equation of conditional distribution of y given x and the conditional expectation of y given x is also given on this slide. The expected value of snow given that it is very cold equals in last example is 0.5. The law of iterated expectations. Law of iterated expectations states that the mean of y is the weighted average of the conditional expectation of y given x, weighted by the probability distribution of x. The mathematical equations along example is also given on slide. Independence. Two random variables x and y are independent if the conditional distribution of y given x does not depend on x. The mathematical equations along example is also given on slide. Mean independence. The conditional mean of y given x equals the unconditional mean of y. For example, if the expected value of snow, y, does not depend on whether it is very cold, x. Means, variances and covariances of sums of random variables. Here you can see the formula of z, mean of z and the variance of z. Carefully study key concept 2.3. There are 7 equations related to means, variances and covariances of sums of random variables. The normal distribution. The most often encountered probability density function in econometrics is the normal distribution is given on this slide. A normal distribution with mean mu and standard deviation sigma is denoted as n, mu, sigma. Standard normal distribution n01 has mu is equal to 0, sigma is equal to 1. A random variable with a n01 distribution is often denoted by z, and the cumulative distribution function, CDF, is denoted by phi z is equal to probability of z distribution is equal or less than value of z tabulated. The normal distribution to look up probabilities of a general normally distributed random variable y is normal distributed with mean mu and variance signs. We must first standardize y to obtain the standard normal random variable, thus z is computed by subtracting mu from y then divided by sigma. In example, we get -2.5 by standardize it. Thus, the probability is 0.0062. The chi-squared distribution is the distribution of the sum of m-squared independent standard normal random variables. Let z1, z2, zm be m-independent standard normal random variables. The sum of the squares of these random variables has a chi-squared distribution with m degrees of freedom. The chi-squared distribution is used when testing hypotheses. In Econometrics table there shows the 90, 95 and 99 percentiles of the chi-squared distribution. For example, the probability of chi-squared distribution at 3 degree of freedom and 5% level of significance is 7.81. The student t-distribution. Let z be a standard normal random variable and w a chi-squared distributed random variable with m degrees of freedom. The student t-distribution with m degrees of freedom is the distribution the random variable z divided by square root w divided by m. The t-distribution has fatter tails than the standard normal distribution. When m is equal or greater than 30, it is well approximated by the standard normal distribution. The student t-distribution is often used when testing hypotheses in econometrics. Table 2 shows selected percentiles of the Tm distribution, for example with m is equal to 5. By observing positive value of two-tailed test, written in center at 5% when divided its significance level by 2 gives 0.0 point for left and right side of t-distribution. The f-distribution let w a chi-squared random variable with m degrees of freedom and v a chi-squared random variable with n degrees of freedom. The f-distribution with m and n degrees of freedom fm, n is the distribution of the random variable w divided by n further divided by v by n. As you see a graph of one tail test of f-distribution with m is equal to 4 and n is equal to 5 degree of freedom. The 90, 95 and 99 percentiles of the fm, n distribution are shown in table 5. For example, with m is equal to 4 and n is equal to 5, then in table 5 the value of probability for f distribution is 3.52 at 10% level of significance. In table 5b the value of probability in f distribution is 5.19 at 5% level of significance. A special case of the f-distribution which is often used in econometrics is when fmn can be approximated by fm, infinity. In this limiting case the denominator is the mean of infinitely many squared standard normal random variables, which equals 1. Appendix Table 4 shows the 90, 95 and 99 percentiles of the fm, infinity distribution. Please subscribe my YouTube channel Thesis Helper. Thanks for watching.